Let's look at one more implicit differentiation problem. This is a problem from homework in WebAssign that I've gotten a couple of questions on. Use implicit differentiation to find the derivative of y with respect to x if x times sine y plus y times sine x equal 4. Now remember, in implicit differentiation you have to realize that y is a function of x. That's got to be your mindset. You don't explicitly know what it is, but you've got to realize that y is a function of x. So you take derivatives of both sides with respect to x. That's always the first step if you're trying to find derivative of y with respect to x. Common mistake I've been seeing with people that have shared solutions in the past is that they might, in place of this symbol right here, they might write dy dx. That's not correct. You're taking the derivative of this x sine y plus y sine x with respect to x. So you want just to write this. This symbol is an action item. It says do something. What does it say do? Take the derivative of what follows with respect to x. This symbol right here just says this is a quantity, this is a function, the derivative of y with respect to x. It's static, it's not dynamic. This is an action item. It says do something. Okay, we've got a sum. So the derivative of a sum is the sum of the derivatives. The derivative of a constant is 0. Now, for each of these, x sine y and y sine x, I need the product rule because they are products. So the first times the derivative of the second plus the second times the derivative of the first. I'm writing my roadmap. The first times the derivative of the second plus the second times the derivative of the first. Now notice one thing about implicit differentiation. It's not like with regular differentiation that you say dy dx or f prime of x is, and then you might rewrite it and say it equals. Each line of this, every single line, line 1, line 2, line 3, line 4, and following, is an equation. It's got an equals here. In every case, it's got an equals. And it's very important that you write it as an equation going up and down the page, because in the end, you're going to have to solve an equation, this equation, for dy dx. So you got to have an equation. Okay, the derivative with respect to x of sine y. Y is a function of x. So you've got an outside function, sine, and an inside function, y. So chain rules necessary. The derivative of the outside is cosine y. The derivative of the inside is dy dx. Derivative of x with respect to x is 1. Derivative of sine x with respect to x is cosine x. Okay, now we have an equation in dy dx. It's algebra from here on out. This equation is of the form az plus b plus c plus dz equals 0. Okay, my z is my dy dx. If I were solving this equation for z, I would say az plus dz equal negative b minus c. Then I would factor out a z. And I would divide both sides by a plus d. Again, this is just algebra. So I'll do the same thing right here that I did here. I'll keep the terms with dy dx on the left. And I'll bring the other terms to the other side by subtracting, since they're added over here on the left. Now, I want to solve this equation. What I'm doing is solving this equation for the symbol derivative of y with respect to x. Okay, now I want dy dx written just once on the left by itself. It's written twice here. Twice. So I factor out the dy dx. And now dy dx is multiplied by this x cosine y plus sine x. So, to undo multiplication, I divide. I divide this left-hand side by x cosine y plus sine x. I divide the right-hand side by x cosine y plus sine x. So I get derivative of y with respect to x equals this.